coming to the message integrity, we have integrity concept from the beginning of this cryptography and network security, where we are discussing about how a message to be maintained from sender to the receiver. When we are saying as a message integrity, we should be very aware that whatever the sender sent message and receiver received message must be same always. If sender has sent hi and if receiver has received hello message, so the message content which is sent by the sender hi and receiver received hello is not same, right? So thus we can declare that some modification has happened in between the communication channel. Like we can directly claim that there is one attacker in between the sender and the receiver who is changing the message or is modifying the messages frequently from sender to the receiver. So for this kind of reasons, we must know about message integrity. Checking with the message integrity is like when we are sending one data to the other person, like hi message, that hi message should be delivered as it is to the receiver. When a receiver tries to take the data, he must have in his hand as hi message only, the original message only, without changing a single bit. Right? This is about the message integrity. Now, how to check with this message integrity, whatever the received data is exactly sent by the sender or not, includes three basic terminology. Those are message, hash function, and the message digest. Now, we have, in the other hand, we have the authentication part also. See, coming to the authentication part is very simple. Like integrity is checking with the message, whatever the sender, uh, whatever the message sent by the sender and received must be same. Message authentication is nothing but who is sending the message, right? So for that, we have one small example that when we are sending one document, we are going to give a fingerprint on that or a one signature on that so that a particularly signed person is sending that data. So that is nothing but the authentication, right? Here we are going to discuss all this now. Now let us move what is message first of all. See here, message is nothing but the plain text, whatever the sender is about to send, right? So the exact document we are sending to the receiver. Now the hash function includes a number of operations. We have a few hash function algorithms also we are going to discuss now. Now the input of hash function is a message, which is the plain text, and the output of the hash function is the message digest. In data structures concept, we say the message digest as the hash code. The output of hash function is a hash code. In cryptographic language, we should call that as a message digest, right? So we are going to have one document, and that document we are going to send as an input to the hash function, and hash function will be giving the output as a message digest that is nothing but properly given with a fingerprint. So that indicates that we are ready with the proper message, which is encoded message. And this message will be also in the format of fixed length format. So that we'll be seeing in the next slide. See here. A map variable length will be of the fixed length size. See, it is here in this basic introductory part, we are going to see our hash function output, that is a message digest, as 64 bits. Like that, we can go to the extension also like 256 bit and 512 bits also, right? So message is a plain text. Hash function is a one of the operation we are going to perform on the plain text. And message digest is the output of the hash function, which is in the fixed length format. If I give the word, my message is hello, and if I send this hello as a plain text to the hash function, it will give one hash code, that is y equal to zeros and ones represented by 64 bits, right? And similarly, if I give ngit, and the output of this will be also of 64 bits. If my data is of 10 to 12 lines, so even though the lines of code also will be giving our hash code as 64 bits only. So this indicates that whatever the size of your plain text may be, but our hash code value, that is message digest, will be fixed with a fixed length of bits. So once we declare as 64 bits, it will be 64 bits only. I hope everyone got till this point. Now let us move. Why we need hash function first of all? We need hash function. See, till now, whatever we have seen, like traditional ciphers to the asymmetric encryption type, and in between we have symmetric type. So whatever the ciphering we have till now, we concentrated on how to encrypt the data, right? How to encrypt the data, how to encode the data, but nowhere we are included what the sender sent and receiver received same or not. We haven't done any operations for that. We encrypted the data at sender side, and at receiver side we are decrypting it. But receiver don't know that this decrypted data is exactly sent by the sender or not. So got this. So this kind of things we need to be known about. The communication channels are very weak nowadays, where we have a number of adversary attacks happening every day. So thus we need to have to check our data properly with the integrity concept. So the need is very, very efficient here. So thus we need this kind of message integrity, where we have to detect the manipulation of your data. So that is what is happening here. See, Alice is sending one message to Bob. In between, Eve is an adversary, where this adversary now has few messages, and she is keep on attempting some messages sent as Alice to the Bob, right? So now how Bob can tell Alice message was modified or not? So there is no such kind of thing which we have learned till now. Thus, we are going to check all those in this point now. Now, for that purpose, we are going to see the main aim of hash function is to check integrity, right? So if our hash code value is very stronger, then as per the slide, even our grandchildren, children's and grandchildren will be gone before that communication, computation finishes, right? So this strong arc hash function should be coded, right? Now, coming to the message modifications, see, LS send one message. LS sends Bob a message. Now is attempting to send one message. So before sending, we encrypt that data M, and we generate one hash code of that particular plain text. Now we send this C and also your value, that is H of M. Now he checks, he decrypts the data C, and at the Bob side, he computes again hash function H of M dash, whatever the value he get should be equal to the value which the sender has sent. Okay. Okay. So this is what will be happening. See, a sender, before sending the plain text, he attempts to apply this to the hash function. Now our hash function MD, message digest, is ready. Now with message digest and this cipher, the plain text given with the encryption algorithm. So whatever the cipher we get, this cipher and this message digest will be sent to the receiver. Now at receiver end, he will be taking C and message digest of the sender. Now he will separate these two. So sender, MD of sender, and take this ciphertext and apply the decryption algorithm, so that you will be getting with the plain text back. So after getting the plain text back, you are going to apply the hash function here, so that you will be getting message digest of the receiver. Now, if the message digest of the sender and receiver are same, then we can say directly that there is no modification of the data done in between the exact sender and the receiver. If these two are not equal, the sender sent message digest and receiver, after receiving the ciphertext and after decryption and giving to the hash function, here he will be getting one message digest, right? If these two are not equal, directly we can claim that something has happened to the communication channel, and we are to check with our communication channel because there is an adversary between the sender and the receiver. So how can we say this? The word hello will be getting one message, I mean the message digest, which is uniquely given, And if you apply this hello to the hash function 100 times, it will be giving this same unique code. And if I give hello 1, so as this string is different than this one, it will give some other unique message digest, right? So if my plain text is hello, and this plain text must be given to the hash function and one message digest uniquely given. Let us say 1, 2, 3. Now this 1, 2, 3, after your hello has been changed, I mean ciphertext has been given as XTWTY. So give this XTWTY and give to the decryption procedure so that you will get a hello back here. Right. After getting your hello back here, you will be giving to the hash function so that you will be getting 1, 2, 3 only. If you are going for 100 times, you will be getting same string, will be giving same unique hash function. So I think you got this. So let us move to the next slide. So for this hash function criteria, we have 3 types, pre-image resistance, second pre-image resistance, and collision resistance. So before building or before we talk about particular hash function, we should be knowing how a hash function should be, right? So what are the criteria characteristics it must satisfy are these 3. Pre-image is nothing but these are the 3 types of attacks to say frankly, pre-image, second pre-image, and collision resistance, where pre-image will be about the hash function, which is, see, our plain text is here and we got the hash after giving to the hash function and we generated. Now, if this message digest has been revealed to Eve, Eve can decrypt the data to get the plain text back, right? So this is one of the pre-image attack we have, and thus we should be, we should ignore this so that we can call this as a pre-image resistance, right? The second one is nothing but we will be giving our message plus the message digest. I mean the hash function output, that is the message digest also. So here Eve is an attacker. So he took this both message and message digest and will be attempting to find M dash, which will be giving the message digest which is sent equal to the sender side. Whatever the sender sent message digest will be there, and attacker will be checking for some other messages which will be giving same message digest. If I sent hi and it has given 1, 2, 3 as a message digest, Eve will be checking for few messages which can give 1, 2, 3 as the hash code message digest, right? So this is the second type of attack where we have to be very familiar with that. And a collision is nothing but where 2 or more messages giving striking to same message digest. So there are n number of messages which can have same message digest, right? So this is what the random oracle model. So this model is nothing but we should be considered about a new message first and convert that into the fixed length of message. Now, when we are discussing about fixed length of message, that should be zeros and ones only. So if I say 64 bits, 64 bits of length of message digest will be created. Now, when we are creating this as a one of the record, so first hello is there. So hello, we will be checking in the record, either hello is available or not. If it is available, just retrieve the data or else give this hello to the hash function so that it will generate one hash code, the message digest, right? Next time you give some other word called model. So model is not there in the record. So you just provide this to the hash function so that it will be provided with the message digest. So like this, we are going to generate all the message digest. If the message is already available in the record, we are not going to generate this hash function. Already existing mode, then we have to retrieve the data. If the data is not available, just give the data to the hash function so that it will provide us the message digest. So this is about the random oracle model. So if you have any doubts in this session, please be free to ask me anytime in the college timings or through comments. Thank you.